Hello, Assalamu alaikum. So today I will be demonstrating my MS project, and the topic of my project is Dockerized real-time streaming data architecture. And first of all, I would like to mention my supervisor's name, Dr. Tariq Mahmood, and his firm support and guidance has helped me to complete this project successfully within the time. And I've learned a lot throughout the semester and throughout my MS program with his guidance and support and his experience in big data side. So now I will briefly explain about what I am doing in this project. I have used containerized form of real-time streaming data architecture in which I have depicted a sensor data generation. I've simulated it in the form of Python script, like the data is generated from a sensor, and then I will show you after processing finally that you will see a real-time dashboard where after every 1 second you can track the sensors data. So let's first look at the architecture. So this is the architecture that I have followed. I have some pool of containers where I have first used my data stream layer, and there I've used Flask container. And I just told you that census data is used in Flask container. The data is generated via API, and that API is then consumed and sent to Kafka via Kafka producer under a topic, and then the Kafka is then consumed by Spark API, Spark streaming, where the data is processed, and after processing, it writes the data to MongoDB. So after it is cleaned and structured, the data is sent to MongoDB, and then Bokeh consumes the clean data from Spark, from Kafka consumer, and shows the interactive dashboard. So let's begin with the Docker Compose file. I have written a Docker Compose file where all these containers are mentioned. I have binded the volumes respectively to my local machine containers, local machine folders. You can see I have placed the coded scripts, beat sensor, Spark processing, and stream to Kafka here in this folder. And I will use it and show you in a bit. I've also bind the inside ports to outside localhost, and I have put all these containers under one network named as Zain network and given them static IPs. So by this, I have been able to achieve and establish communication among these containers. So let's see further. I have Spark containers as well and Bokeh here. And I've compiled a few lines of commands that I will run to demonstrate. So first of all, let's make our containers up. So from here, I will copy this command and make our containers up. So you can see I've used Docker Compose command where I've mentioned the file name and I've navigated to the directory where Docker Compose file is placed in. And this is all running in detached mode. Now you can see all my containers are up. And to validate that, I can run Docker PS and you can see all my containers are up and running. So we have a GUI view as well. And you can see the ports and IPs in Docker for Windows here. And this makes it very easy to use as you can navigate to any container using its CLI command and run any command in that container. So now I will demonstrate that I will show you my beach sensor script, which is automatically started as I ran the Kafka, as I ran the Flask container. So it is hosting on port 5000 and it is generating sensors data, simulating it. I've used some random variables to show that every time when we hit the API, a new data is generated. So to validate that, we'll just go to localhost and I will go to this. And you can see every time I refresh it, I'll get a new data set. So this is sensors data depiction here. Apart from that, now we will run stream to Kafka script, which will go to this API, which I just showed you, and hit after every 1 second and generate data. And it will send to Kafka topic named sensor data via Kafka producer. So now let's run this file. And I will run this file in the Kafka container. So in Flask container. So this code is in Flask container, and it is communicating to Kafka via the producer, and I have under the bridge network. So you can see the data is printed here. So this is coming from the script, whatever it is sending to the Kafka producer. So we can also validate it by going into the Kafka container and looking under this topic sensor data. So now I will open Kafka container and run this command. So you can see now it is hosting from the sensor data topic, and you can see all the data from beginning what is sent. So next we will move towards the Spark processing code. Now I will run this code, which is also placed in Flask container, and it is connecting to the Spark container using the architecture of Spark master and worker node from there by giving this path. And it is taking in the data from the topic by Kafka consumer. And after it will validate and structure the data in a specified format. And then it will send the data to another topic named as clean data, and it will also push the data to MongoDB under the collection streaming data collection under streaming data DB. So let's run this file as well. So I will go to Flask container again, and I will run this file. So you can see as I ran this file, let's open the Spark node as well here on that IP, which is binded on localhost. And I think it is 8080 for Spark. Yes, you can see 2 workers are here and a job is running here. And I was assigned the configurations here, and it is working according to that. So the job is running now in under Spark, it is processing. So after that, let's look to the next part. Now, after this, I will also demonstrate, I've used this MongoDB compass to show how MongoDB data is pushed. You can see it is generated, it is updated every second. So in this format, it is stored in MongoDB. So we have storage here. And for real-time tracking, now I will move to Bokeh container. And for that, let's go to Bokeh container and run this command. So I will open Bokeh container from here, and I will run this command. So it is hosted on 5006 port. So let's go to 5006 port from our local browser and see what we get there. I think I made a typo error. Yes, so you can see the data is shown at every timestamp, and it is tracked on every real time. So this is just a proof of concept to show that how we can track this data. And once we are able to track the IoT sensors data, we can make decisions timely and make interactive and beautiful dashboards, and that can be seen by the stakeholders. And we can make any complex sort of calculation as well. I have shown a very simple tracking as a proof of concept. So this is the complete demonstration of my project. It has an application in multiple areas, in environment as well, in agriculture as well, where temperature is to be monitored, and a lot of amount of money can be saved by tracking census data and many other use cases as well. So I will also share this final report, which has all detailed information about all the components used. And I have also mentioned the whole workflow with screenshots here of this demonstration. Thank you very much.